So today we're starting chapter 7, and our first lesson is going to be on using the properties of exponents that are involving products, which is basically multiplication. So there's 3 properties we're going to go over today. So the first property that we're going to do is called the product of powers property. So remember, product is what you get when you multiply two things. So this is essentially saying, what do you do when you're multiplying two powers? So first of all, you might be saying, wait, what is a power again? So if we think about this, a power is an expression written so that you have a base value raised to some kind of an exponent. So the larger number, physically larger number, is the base, and it could be a number, it could be a variable, and then you have that exponent, which is that little teeny superscript, a little number that's being raised up to. So in order to multiply powers having the same base, you're going to add the exponents. And so let me explain to you why that is. So if we're simplifying this expression here, and you have 2 to the 6th times 2 to the 8th. Well, before we do that, let's pick up another example. So let's say I'm going to do 3 to the 2nd power times 3 to the 4th. Well, what does that really mean? 3 to the 2nd power means that I have 3 times 3. That's what that is saying. 3 to the 2nd power is 3 times itself 2 times. And then I'm going to multiply that by 3 times itself 4 times. Okay, so here's my group of 4, here's my group of 2. So altogether, I'm multiplying 3 by itself 6 times. So the shorthand way to do that is simply to just add the 2 exponents, because then you know how many times that base number is going to be multiplied by itself. So for this first example then, we would have 2 to the, we would add up the 6 and the 8 and get 14. So it's 2 to the 14th power. Now the next example here, we have a -3 being raised to a 7 and then times another -3. Now remember, every number has an exponent. If there's nothing visible there, that means it's just raised to 1 because it's just the number itself. So this then would be -3 raised to the 8 because 7 plus 1 is 8. Now notice when it's a negative number, I have to keep it in the parentheses because when you're raising a number to a power, you're multiplying it by itself. Well, we're not just multiplying 3 by itself, we're multiplying -3 by itself however many times. And if it's an even number of times, those negatives will cancel out and become positive. But if you don't have the parentheses there and you use this calculator to maybe get the actual value for this, it won't work unless you have the parentheses. So keeping that in mind, looking at number 7, again, our base number here is -7. So I'm putting that in parentheses. And then I have a 3, a 4, and remember this is really a 1 here, so it's -7 to the 8th power. And then finally, example D, again, if there's no exponent, it's really a 1. So I have m to the 12th power there. Okay, so just doing a few practice problems for these. Number 1 would be 8 to the 14th, just adding up the 3 and the 11. Number 2, 6 to the 4th, adding up the 1 and the 3. Number 3 would be y to the 11th, 3 plus 6 plus 2. And then number 4, we have -10. 2 plus 1 plus 5 would be 8. So -10 to the 8th. Noticing I'm keeping that base number, if it's negative, in parentheses. Number 5, this would be 7 to the 9th power. Number 6, x to the 4th. Again, remember these numbers that do not have a visible exponent really have an exponent of 1. Number 7, y to the 8th. And number 8, z to the 13th. The second property we're going to go over now is the power of a power property. And in this case, to find the power being raised to another power, we're going to multiply the exponents. So for example, if this is 3 to the 3rd power here, raised to the 6th. Let me do a smaller example so I can kind of write it out. So let's say you had 2 to the second power, and you had that 4 times. This means that you have 2 times 2, because that's 2 to the second power, and you're going to have that 4 times. That's what that means. So of course, if all of these 2's are being multiplied, how many 2's do I have here being multiplied? Or how many times is 2 being multiplied to itself? 1, 2, 3, 4, 5, 6, 7, 8. But it would be much quicker to just multiply the 2 and the 4 and get the 8 that way. So here we have 3 to the third raised to the 6. So we're saying we want to multiply 3 by itself 3 times and then do that 6 times. So 3 times 6 is 18. So this would be 3 to the 18th power. Okay, example B. We're going to take the negative 12. Notice I'm keeping my base in parentheses since it's a negative. And 7 to the 6 would be 42. Example C, D to the 10th, because 5 times 2 is 10. And D, again, if my base is in parentheses, leave your base in parentheses. You're just focusing on taking your exponents and multiplying them. So this would be x minus 3 in the parentheses to the 12th power. So some practice problems for this. Here we would have 13 to the 30th, because 3 times 10 is 30. Number 10, negative 8 in those parentheses to the 21st power, because 7 times 3 is 21. Then number 11, we would have f to the 64th power. Number 12, like I said before, anything in parentheses, leave it as is in the parentheses. 9 times 2 is 18. Number 13, 2 to the 20th, because 4 times 5 is 20. 14, 3 times 7 is 21, so we have 6 to the 21st power. Number 15, 4 to the 18th power. 16, m to the 28th power. I'm a little too fast here. And number 17, b to the 18th power. And finally, number 18, 5 times 3 is 15, so this would be p to the 15th power. Okay, so our third property that we're going to go over today that involves some multiplication is the power of a product property. So this time, you have 2 things being multiplied, which is what a product is, right? It's the answer you get when you multiply 2 things, and there's going to be an exponent on the outside. Now, what that means is that each of the terms or each of those things that are part of that product are going to be exposed to that exponent. So if you have the 2 items separated, like you do in example A here, it's pretty easy because you're just going to make sure that that 4 is on each of those terms. So you have 16 to the 4th times 21 to the 4th. That's all you have to do. It gets a little trickier though when you have variables and constants mixed together. So I have a 6, that's one term. I have this m, and I also have this n here. So I have 3 terms here. This little 3 needs to go to all 3 of them, and this is where sometimes people get a little confused. So we have a 6 to the 3rd power times an m to the 3rd power times an n to the 3rd power. Now, the m and the n, there's nothing else I can do there. The 6, however, if it's something that is you can work it out, and I would check it on a calculator, and the number's not like astronomical, you would want to work it out. So on your calculator, you would do 6 raised to 3, and you can see that's 216. Now just to, so this would become 216 m to the 3rd, n to the 3rd. And in our final answer, we just typically don't write the multiplication signs anymore, but you can leave them in there as long as possible. Now, for this example here that we had done in A, 16 to the 4th and 21 to the 4th, I could have worked those out. If I did 16 raised to the 4th, I get this number into the thousands, and then the other one was 21 raised to the 4th, Again, another number in the thousands, and then I'd have to multiply those together. So you could do it, but usually when we get numbers into the thousands, we're not so worried about working it all the way out since the directions just indicated that we could simplify. We don't really have to do that part. Okay, so let's take a look at example C. Now this time we have a negative number inside, but remember negative numbers always have to stay in parentheses. So this -5 is going to get a third power. And then that p is also going to get a third power. Now I want to work out my -5 to the third power. I'm going to use my calculator. -5 to the third power. And it works out to be a negative. Now when you have an odd exponent, you will get a negative answer. So in this case, it was -125. You no longer need the parentheses because you don't have the exponent on that number anymore. Now D is a little different because we can see that our exponent is on the outside. So we're going to basically just multiply a -1 to our answer. So this is what's going to happen. I have this -1, and then I have 2 to the fourth power. The -1 doesn't get the 4 though because it was outside the parentheses. And then the q, which is inside the parentheses, also gets the fourth power. So I have -1 times 2 to the fourth, which is 16. If you don't know it, put it in the calculator, and q to the fourth. Now -1 times 16, make that a -16. I don't need parentheses around it though because there's no exponent on that 16, and that's my answer. Now some people will just choose to work out this portion here and then just put the negative on the answer at the end. So some practice examples for these. So this one, we can just leave it as 13 squared times 18 squared. Number 20, 21 to the fifth times 25 to the fifth. 21, 7 to the sixth times 154 to the sixth. 22, 5 to the sixth times 18 to the sixth. So now let's apply this to some problems with variables as well. So this one we would have 3 to the third times n to the third. 3 to the third isn't too big, so we're going to do that on our calculator. 3 times 3 times 3, or 3 cubed, and you get 27, and then you need your n to the third. For 24, you would have 2 to the fifth times x to the fifth. 2 to the fifth can be worked out on your calculator. You can get 32 times x to the fifth. Number 25, you have x to the sixth times y to the sixth, which of course cannot be worked out on a calculator. So your answer is just x to the sixth, y to the sixth. And then number 26, we have one of those ones with the -1 on the outside. So it's going to be -1 times 11 to the third times p to the third. Now 11 to the third, if I go to my calculator, 11 to the third. Now be careful, it's not -11 to the third. That negative is a separate number. So it's 1331. So now if I want to, I can multiply my 1331 times the negative, and I can get -1331. But if you had tried to do the negative before you did the power, it may not work out correctly, so you have to be careful with that. All right, and then finally, we're just going to do a few problems where we're using all of these properties in one problem to simplify it. Now, I tend to kind of use my order of operations, which is parentheses, exponents, multiply and divide, add and subtract, as a way to help me remember what to do. And you don't have to do this order with exponents. You do when you're simplifying just algebraic expressions, but for exponents, it's just a reminder, really. So I like to get rid of the parentheses first, and the way that I would get rid of my parentheses is by distributing. It's not really distributing, but by bringing this exponent to each of the numbers or terms inside. So that's the first thing I'm going to do. So I have -3 to the third power times y to the fifth, which is also to the third power. And then I also have this times 2 and times y squared. So after I kind of get rid of that exponent on the outside of the parentheses, I'm going to solve whatever exponents I can. So negative 3 to the third power. If we do that on the calculator, negative 3 to the third power is negative 27. So I have that. Now here I have y to the fifth to the third. Well, remember that power of a power property, we multiply these two. So this is going to become y to the 15th. And at this point, we want to do any multiplying and dividing. So negative 27 is just going to get multiplied by 2 as you normally would. It equals negative 54. And then when you multiply the y to the 15th times the y squared, if you remember the first property we did today, the product of two powers, you add those exponents. So this would be y to the 17th. So this would be your answer for that. All right, so let's try another one. Now this one, we have an exponent on the outside, and it's going to go to the negative 3. It's going to go to the x squared, and it's going to go to the y to the 5th. So I have a negative 3 to the second power, an x squared to the second power, and then my y fifth is also going to get a second power. Now, anything that has a power to a power, you're going to multiply those two. So this will become x to the 4th, and this one will become y to the 10th. And then negative 3 to the second, you could work out in your calculator, negative 3 times negative 3, which is actually a positive 9. And this is where those calculators are, or in parentheses, are important. Because if I did negative 3 to the second power with my parentheses, I get a positive 9. But if you forgot your parentheses on this problem and you typed it in your calculator, you would get a negative 9. So with the even exponents, it's super important to remember your parentheses or you will get the wrong sign on your answer. And so then this can just be condensed without the multiplication signs. We can just put the terms right next to each other, 9x to the 4th, y to the 10th. All right, and then our last one here, again, I want to get this little 3 on the outside. I want to make sure each of those numbers in the inside get that exponent. So I have 2 to the 3rd times m to the 3rd, and then over here, I'm going to have my m to the 4th to the 5th power. So 2 to the 3rd is 8. And m to the 4th to the 5th, I'm going to multiply those two, giving me m to the 20th. And then finally, I can add these two exponents because I'm multiplying. So that's going to be m to the 23rd. So that's our overview of the 3 properties that have to do with products and powers. And we'll continue on tomorrow with a couple more properties.